is Module 10, Practical Interior Lighting, the last of 10 modules for this V-Ray training series. Just as I did in Module 9, Practical Exterior Lighting, here I want to demonstrate several different ways to approach lighting the scene. Not only will I cover many different light source types commonly used for interior lighting, I'll put numerous different render and material settings to the test to show you how to get different looks to your images and precisely control the relationship between speed and quality. Before I begin, just like I did with Module 9, I need to give some background information about the scene that we're going to be working on, and I want to also address some workflow issues that I think are important to mention early on. I'll start by showing a panorama of the scene that we're going to be looking at, and this is a good scene to demonstrate on, I think, because it's not too small, it's not too large, it's not too simple, and it's not too complex, and it contains some fairly decent architecture and design. It's a two-story condominium, and it's one of 5 units in this one building, and this panorama shows the view from the living room, and here's another showing the view from the master suite, and finally the view from the dining room. This scene was created for a development called Lusso Villas. Lusso, which means luxury in Italian. Lusso Villas in Naples, Florida, and from the outside, this is what the building looks like. As I said, it's a multi-unit condominium building, and the unit that was built in 3D is this N unit right here. It's quite a nice design containing an enclosed pool area, and from a different view, you can see an up-close view of the exterior of the unit. Here we illuminated the scene, the exterior here, with single direct light, but as we'll see, using a single exterior light just won't be sufficient for an interior scene. The areas that I'm going to be focusing on are the 3 rooms that I showed in the panoramas. The living room is behind these sliding doors here, the dining room is behind these windows here, and the master suite is located on the other side of the living room. And here's a look at the floor plan. The exterior image was a mirrored version of this floor plan, but nonetheless, this is the unit that I'm going to be working on, so the scope of the project only included these 3 rooms, the living room, dining room, and the master suite. Notice that it's a 2-story unit, and that makes the scene a little more interesting to work on and gives us a little more work to do. Also notice in the panorama files that the rooms are fully furnished. These panoramas show the project is completed, but in the max file that I'm going to be starting on, there's no furniture because just like the excluded vegetation and cars and other things in Module 9, you really need to do the majority of your lighting tests without all the extra polygons that come with this furniture. Included in here will only increase render times when you do your test renders, and besides this, I wouldn't usually even have the furniture to place in the scene at the time which I start working on the lighting. There's a certain workflow that I recommend following for any 3D project, and before beginning any work on the materials and lighting, I always send QuickTime panoramas to clients asking them to verify the architectural correctness of what they see. And then and only then do I proceed with materials and lighting. So in this scene, here's an example of what I would send to the client. And from this, they can tell me if something is amiss or if something's wrong, and I can correct it early on and not waste time redoing any material or lighting work. It also gives them more time to work on providing me the materials and the furniture, which for me always seems to be the last thing that they have ready. If I was fortunate enough to have the furniture selections provided early on, I would have those custom pieces worked on concurrently with the 3D scene so that no time is wasted. But the bottom line is, if I had the custom furniture already built or the stock furniture already picked out before the material and the lighting phase began, I would still work on the materials and the lighting before inserting the first piece of 3D furniture. The 3D furniture obviously has a major impact on the way light bounces around the scene, but not so much so that it justifies conducting test renders with all those extra polygons. Well, this is not a discussion on Max and how to apply textures and mapping, so for the purpose of this demonstration, I'll start working on a scene where materials and mapping are already applied. What I will do, however, is change some of the already applied materials to show some of the changes that you might naturally want to make through the various V-Ray settings available. For example, I'll add glossy reflections to the floor. Before starting this tutorial, I would recommend downloading a plugin called Color Correction. It's not a requirement at all, but some of the materials in the scene take advantage of this plugin, and if you don't have it, you'll receive a message indicating that you have a missing file when you try to load the scene, or when you at least try to merge the furniture into the main scene. You can download this plugin at no charge from this website you see here, cunitozdás.com, and I'm not sure I even pronounced that correctly, but as you can see from the description on the website, Color Correction or Color Correct is a 3ds Max texture plugin which alters the colors of any bitmap or procedural texture so that you can fine-tune the colors or create a variation of it. So let's go ahead and get started. And if you want to follow along in this scene, open the file luso-01.max. The first thing I want to point out is this scene will never contain objects that you wouldn't see from the inside of the unit. In other words, just like I don't include furniture at this point, there would be no reason to have objects like cars or trees or vegetation or pavers that you can't see directly from inside the unit. So whenever possible, always try to keep your interior scenes self-contained and keep your outside objects minimal and as few as possible. So whenever you're required to build both an interior scene and an exterior scene like I did for this particular project, I would recommend creating 2 separate scenes whenever possible. And there's numerous reasons why you would want to work this way rather than the obvious benefit of reduced file size. And as a side note, after the lighting and render settings are established, I'll merge all the furniture shown in the panoramas, and you can do this as well by merging the file luso-furniture.max. All the furniture in the scene was custom made, so feel free to use it in any of your projects if you like. With all that being said, here's the 3D interior scene for this project. The scene contains 61 objects and over 600,000 faces. There's 5 cameras for each of the different perspectives that I'll be working on, and there are 5 lights which are only used to illuminate the background objects. I have my typical background rig here, which I use on almost all of my scenes, both interior and exterior. And as you can see here, all the objects are explicitly named, and if you analyzed each object, you would find that most are collapsed down to an edible poly or an edible mesh, except for some that require a UVW map modifier. So with that exception, everything is collapsed down to its base mesh or poly object. I want to point out that the walls, the windows, doors were built with the box modeling method, i.e. primarily using the edit poly method, the edit poly modifier. And instead of keeping them together as one multi-subobject element or object, the different elements were separated so they could be hidden and isolated individually. There's an object called building wall top, which looks like from the outside that it might be the second floor ceiling, but it's really not. This object was just a leftover object from box modeling, and another object exists that represents the ceiling and the floors. This wall top object obstructs the view of the interior scene, which from the outside it does, which is why I will hide it from time to time to view the interiors from the outside. But I don't want to delete it because leaving it can help prevent the possibility of light leaks through the walls and through the real ceiling. There's numerous window and door openings which I'll have to deal with from a lighting standpoint, and if I hide this main building object, the main wall object, you can very clearly see everything in the scene. There's no lights in the scene at this point except for the background lights that illuminate the background objects, and if I render right now I would see nothing but blackness. Before I add my first light, I'm going to enable environment lighting and render the scene with just environment light so that you can see all the settings that I adjust when I do this job for real. And I'm going to make adjustments to the default render settings so that you can see the lighting in the scene develop from scratch. So when you open up the scene, the render settings that you see will be the same render settings that you would see if you had V-Ray 1.5 loaded from scratch. So instead of manually changing all these settings, I would usually just load my interior test render preset from the system rollout, and that would save me a lot of trouble of doing what I'm doing now, which is manually changing all the settings that I want to change for these test renders. Now, in some cases, I'll just make adjustments to settings and explain why I made the adjustments, but if I've already explained numerous times before the reasoning for the type of adjustment that I'm making, especially those that I made in Module 9, I'm going to refrain from repeating the same thing over and over again and instead try to spend most of the time in this module demonstrating features that I didn't get a chance to reiterate earlier. So the very first thing I need to do is, of course, enable GI. And once I do that, I want to leave the irradiance map as the primary bounce since it's so fast, but I want to change the secondary bounce to light cache for really the same reason. Now within the irradiance map rollout, I definitely don't want anything even close to a high preset. I wouldn't use this even for a production render, but here for test renders, I want to use a very low preset because it's very fast, and I want to change the hemispheric subdivisions to 20. I'll leave everything else in this rollout as is at their default values and move on to the light cache rollout. Only thing I want to change in the light cache rollout is subdivisions, and I'll use a really low value of 100 for now, so that'll make test renders very quick. Next, I want to go to the image sampler, and because of all the large, smoothly shaded surfaces, this scene is a perfect candidate for the very fast adaptive subdivision sampler. Although this may certainly change once I add furniture and other details, for now I'll leave this sampler enabled. I just wanted to point it out because image sampling is so important. I don't want to change it though. I want to use this sampler, and the default values are really ideal for quick test renders. So I'll leave everything here set as is. Since I'm using a 3D background rig, I can't possibly see the background color inside the environment effects dialog box, so I don't need to worry about changing this color unless I want it to provide skylight. I use the V-Ray Sky Map in Module 9 to provide skylight, and just to do something different here, I won't use the same thing now. I won't use the Sky Map now. Instead, I'll use a color swatch, but not the one here inside the environment effects dialog box. I want to control this environment light, this skylight, inside the render scene dialog box. So inside the environment rollout, I'll enable the override, and the color, the light blue color that I see right here, is actually perfect for a midday sun scene. So I'll leave this color set as is. Just like I always do, I'm going to start my color mapping at Reinhard with a burn value of 0.5 and adjust from there if necessary. But I really don't expect to make any adjustments to this anytime soon until at least after I've added most of my lights, because all of the lights will have an impact on the final color mapping settings that I use, and if I try to do this too early, it's just going to be a waste of time. Nonetheless, I have to start with something, and I'm more likely to end up with some degree of exponential color mapping rather than none, which is why I've set this to Reinhard with a burn value of 0.5. So this is better than just using the default linear option, which is almost always going to give me some burned out areas. So either exponential or Reinhard with a burn value of 0.5 is a good place to start. I also want to enable these two options here, subpixel mapping and clamp output. These are two options I always enable by default, and I consider them a necessity, and they have a negligible impact on the render time, but they certainly have a tremendous impact on the quality of your rendering. Next, I'll go to the QMC sampler rollout, and since I'm not going to be using HDRIs in this scene, I'm going to set the adaptive mount to 1.0. Increasing this value can speed up the rendering a lot, and even though it can also increase the likelihood of splotches, especially when I use things like HDRIs, I'll try to combat them in other ways first if they do appear. The noise threshold value can be left at 0.01, and with that I think I'm ready to do the first test render. This rendering will take just a few seconds since I have no lights and very low render settings, but whenever I use environment light, which would be for almost any scene, I like to render with just the environment light so that I can see its effect without any other light source, so that I can know that for sure when I place that first light what the illumination is in the scene that's caused by the light and how much illumination is being provided by the environment lighting. So this is what I get when I render with just environment lighting. Well, like most scenes, the first light that I should place in the scene is the light that represents the sun because it's the strongest light source. In Module 9, I used a V-Ray Sun to simulate the sun, so this time I'll use the only other light type that I use for the sun, and that would be the standard direct light. I want a little bit of direct light to shine on the floor in the living room, so I know that I need to place the light somewhere on the left-hand side of my scene as shown in this view, which would actually be the right-hand side of my scene looking in the top view. So I need to place it somewhere about here. I want to make sure that enough of it comes through these windows here, so I don't want to move it too far up and down as seen in the top view. And I want a midday sun scene, so I need to place the light fairly high in the sky, but not so high that the direct light shining down can't make it through the windows here. So just like the exterior scene in Module 9, I'll place it about 60 degrees up in the sky. And that's just the typical angle that seems to work best in most of the midday scenes that I work on. Now, since this light will serve as the sun, I need to obviously have shadows created. So just like any standard or photometric light, I have to use V-Ray shadows. So I'll enable V-Ray shadows for this particular light. Even though I know I'm going to add numerous interior lights, I always like to see the effect of this first single light. So I want to render the scene right now before I add anything else. And these first few test renders are only going to take a few seconds, but after this rendering, I'm going to have to just show the end result because the render times are really going to start to grow with each light that I add. And I don't want you to have to wait for the rendering to finish. It might be hard to see because it's so dark, but just like most interior scenes where only a small percentage of the outside sunlight is allowed to come through, I have a tremendous amount of splotchiness. And I certainly have a low amount of illumination. I could use a very high intensity multiplier on the sun, and I could then use color mapping to compensate for the areas outside that would be too bright once I increase that light. And I could also adjust areas inside that would be too dark, but I would have to use extremely high render settings to keep the blotchiness down, and this would only mean longer render times that I'm not willing to accept. And it still probably wouldn't look as good as if I just used fill lights inside the window openings. I do intend to use a lot of artificial interior lights, and that'll certainly combat the effect of splotchiness, but even with plenty of interior lights, I want to use fill lights for all the window and door openings. And I want to place the fill lights in these openings before adding interior lights because I want to get the natural light as realistic on the interior before adding artificial lights. And this is really an important point to understand. You really want to add the artificial lighting after you get the natural lighting from the exterior sunlight correct. And if you do this, if you wait until this point when the natural light is correct, you can know that when you add the artificial lights, you would know that the changes that you see are realistic or not. But before I can do that, I need to make sure that the outside of my scene is illuminated realistically right now, because the outside is only illuminated by one light, the light representing the sun. And if I don't get it right now, I'm setting myself up for failure because I'll have to adjust the sun intensity multiplier or color mapping eventually, and doing it after I've set up my interior lighting will only mean that the interior lighting will be completely thrown off. If I hadn't switched to Reinhard color mapping and dropped the burn value to 0.5, I probably would have these outside surfaces illuminated just fine, but I know from experience that linear color mapping with the default settings is just almost never going to work because there's always going to be burned out areas. And this is why I enabled a little bit of exponential color mapping from the start when I enabled burn value of 0.5. So I don't want to touch the color mapping right now. I want to do the only other thing I can do, which is increase the sun's intensity multiplier. Based off what I see right now, I'm guessing I can go from a value of 1.0 to 3.0, and that would probably do the trick. So I'll increase the intensity multiplier to 3.0. And I also want to change the color of the light from white to peach, just to give my surfaces a little more color depth. And I do this to all lights, interiors and exteriors. A little bit of color, whether it's light yellow, light blue, really can add to the depth and give your scene a little bit more warmth. So with the changes to the sun, rendering my scene goes from this to this. And with this last change, I'd say the exterior surfaces seem to be illuminated just fine, so I won't make any more adjustments to the sun. I'll leave the outside as is. For the interior part of my scene, the first thing that jumps out to me as being unrealistic, besides the lack of illumination, of course, it's very dark, The first thing that stands out is the sharpness of the shadows created by the mullions in the windows here. And the best way to fix this is to enable area shadows. So with the sun still selected, I'll enable area shadows, and I need to increase the UVW size because the default values will be too low to have an effect. I know from experience that a value of about 3 feet works well, so that's what I'll use here, 3.0. With this change, the rendering looks like this. And I can't tell if there's any noise to the shadows here on the floor, so just to find out, just to see if there's any room for improvement, I'll increase the shadow subdivision from the default 8 to 20. And I also want to enable smooth surface shadows to help reduce the chance of any noise appearing. With these two changes, my rendering changes from this to this. And I didn't see really any significant change for the shadows on the floor, so I'm confident that I don't see any noise at all. Anything that I'm seeing is just a blurring or a mixture of the blur and the texture. So there's no indication I have noise at all, so I really don't need to worry about adjusting this anymore. One more thing I want to point out, just like all subdivision settings anywhere in V-Ray, whether it's for material reflections or refractions, blurry reflections or refractions, for light shadows, you can only go so far with the shadow subdivision or whatever subdivision you're trying to adjust. So if you don't have the noise threshold set low enough inside the QMC sampler rollout, the subdivision value that you specify for any given setting won't make any difference. So I could set the shadow subdivision to 100 if I did have noise, and if that QMC sampler noise threshold value wasn't low enough, wasn't as accurate as it needs to be, that shadow subdivision or material subdivision setting won't mean anything. So with these last two changes that I made, these last two settings, it didn't seem to have any impact on the shadows from the sun hitting the floor here, but notice a few things. On the outside, there's some changes going on as I flip back and forth from one image to the other. There's some changes going on to the shadows on some of the outside surfaces. And also there seems to be some sort of light leaking here in the corner, and it might seem like I should disable this option, but I'm not going to need to. Any of these changes that are going on outside and this light leak, if that in fact is what it is going to be washed out, is going to be overshadowed by all the interior lights that I'm going to fill with the scene. So I don't have to worry about any of these small little artifacts appearing, if they're even artifacts, if you want to even consider them artifacts. So I'm finally ready to start adding light planes to all of these openings. And basically anywhere outside light can come in, that's where I want to add these V-Ray light planes. And the very first consideration I need to make is whether to place the lights just inside or just outside these openings. And what determines that is whether or not there's any objects that would interfere with the lights. I know that I can't allow any objects to intersect or touch the plane, the V-Ray light plane, because it can cause erratic lighting. So if there's any objects just inside these openings, such as curtains or drapes or any furniture, I might need to place the light outside. But I'd always prefer to have the light inside the window or inside the door frame because placing it outside wastes a lot of the light, especially when you have more tinted glass. It has to go through the tinted glass. But if there's any objects that would interfere with the light, then you would simply have no choice. Even if an object like a chair is just a few inches away from the window or door opening, but it's so close that it actually occupies the same space as the light, I would still want to place the light just outside because you can easily have an unrealistic hotspot appear in your objects that are very close to the light. But with that one exception, with the exception of objects that are just in front of the window or door opening, I will always want to place the light just inside. Just like I place the strongest light in the scene first, which is the sun, I suggest placing the strongest fill light in the scene first because all future lights that you place, all future fill lights, need to be given an intensity value relative to all the other lights. And it's a lot easier to place the strongest lights first rather than placing the weakest ones and trying to find their perfect intensity value only to have to change the first set of lights that you place because they were overwhelmed by the stronger lights and so forth. I can always play with the intensity of all the lights after they're placed, but what I'm most concerned about right now is getting the relative value of all the lights correct first from the start, the relative strength of each light that I place. If I do need to adjust all the lights later, I want to adjust them the same relative amount. In other words, if I have a light with an intensity value of 10 and I need to change it later to 20, well then another intensity value for another light that's set to 5 would need to change to 10. So if I double one, I need to double all of them. So the biggest thing that I need to keep in mind right now when I start assigning intensity values to all these lights is the total amount of light that would naturally be coming in each window and door relative to the other windows and doors. In other words, if I look at this panorama and I know that the sun is off to my left coming in the left side of the house, then it would stand to reason that the intensity of the fill lights on the left-hand side of the view would be greater than intensity values placed in openings on other sides of the building, not facing the sun directly, like the windows or doors behind me, directly in front of me, these sliders in front of me. Any windows off to the right-hand side, there aren't any, but if there were, those windows and door openings would have intensity values less than the window and door opening fill lights that I have here on the left-hand side of my screen. So from the outside, it looks like in this scene, I should start placing fill lights in these three windows here on the second floor. To place a light in these windows, I should switch to the right view so that when I place the light, it's already oriented in the proper direction. So I'll switch to the right view and zoom into the area that I need to place the light. And I need to go to the V-Ray light. And I need to create the light fairly carefully. I need to make it close to the extents of the glass, or at least the window frame, basically where the light can actually come through. It doesn't have to be perfect, but I usually try to get it within an inch when I'm doing this. That's accurate enough. So I'll just move it around till it's centered on the glass and filling the extents of where the light can actually go through. Since all three of these windows are the same in terms of size and orientation, after I make one, I should definitely just create an instance and move two instances where the other two windows are. So I can just hold down Shift, apply the move transform, make two instances, and once I create the instances, I can select all three, switch to a perspective view, and rotate the view so that I can make sure that these lights that I just created don't intersect the wall at all. So I usually have to play around, move the view around, adjust the lights, move the lights so that they're just in front of the window frame, just in front of the window opening. And I'll probably best see this if I'm in shaded view, but when I'm in shaded view, I have to make sure that the top of this wall is hidden. So I have to select the window, the wall top, hide that wall top. And I'm just trying to get a nice perspective view of the interior where this light is going to be. And it takes a little bit of time, but once I get the light just in position, I just want to check to make sure that I can see the boundary of all sides of the light and that it doesn't interact with any object. And once I do that, I know my light is set. And since all three of these are instances, if I change one light, all three will change. Also, I could have created just one light to encompass the extent of the three openings, but I really don't like to do that if I don't have to. If I did this for a light on the inside, you might see the same amount of illumination all along the top boundary of the light bouncing onto the ceiling, instead of seeing light brighter in areas right in front of each window, which would be more realistic than seeing the same amount of illumination all across the top, even in areas where there's no window directly below the ceiling. So in this panorama, it looks like the same amount of light, same amount of illumination is shining all along the ceiling. It's probably not necessary to create three individual lights, but as a matter of rule, I like to take the few extra seconds to do it. It's not very time consuming, and it's usually just more accurate that way, because then I don't have to worry about how much light is coming in between the windows where there's really no window, instead of having a more accurate indication of light coming in right where those windows occur. So if they were several feet apart, you would definitely see the benefit of using individual lights, but these windows are fairly close together, and because they're fairly close together, I could get away with using one light, but again, I just, as a matter of rule, always like to put a light in each individual window or door opening. Now that the light is in place, I need to give it a color and an intensity value. These two variables work in conjunction to specify the total intensity value of each of the three colors that make up a pixel, which is red, blue, and green. And this is really important and really critical, and I want to make sure this is understood, so I want to demonstrate something with a different scene. So I'm going to switch scenes temporarily and look at this scene where I have a simple teapot and a V-Ray plane, two objects. I also have a V-Ray light plane serving as the only source of illumination. If I select the V-Ray light plane, notice that the intensity multiplier is set to 10, and the color of the light is gray, and the exact value of the RGB components is 100 for each. And I want to render as is, and when I do, this is what I get. Nothing spectacular, but watch what happens when I increase the intensity multiplier tenfold to 100 and reduce the color value of the light tenfold, changing each component from 100 to 10. When I render, I see absolutely no difference to the image, and it's because of the amount of light being projected. It's exactly the same. So when I change the light, I offset it by changing the color, and I can do just the opposite. If I change the color, I can offset it by changing the light. In other words, if I had black as the color, it wouldn't matter what the intensity value was set to. And likewise, if the intensity value was set to 0, it doesn't matter what the color would be set to. Even with pure white, I would see no illumination. So this just demonstrates the relationship between the color of the light and the intensity multiplier. Now watch what happens when I double the intensity multiplier to 200. And I exactly offset this by cutting the total RGB combination in half from a combined value of 30 to a combined value of 15. So let's try 10 for the color red, 5 for green, and 0 for blue. So I double the intensity multiplier of the light, and I cut the color of the light in half to offset that. So when I render again, I again have the exact same amount of light being projected. It just happens to have a different color, a different hue and saturation value, because I gave a different value to each of the red, blue, and greens. So, and this concept is important to understand. It's important to understand the relationship of the light and the color, especially when you're talking about an interior scene where you're having to use a lot of V-Ray light planes to simulate skylight. Getting back to the interior scene for the Lusso project, for this scene I could use any combination of color and intensity value for the various V-Ray lights, but I want the light coming in through the window and the door openings to have a light blue hue to it, just like the color of skylight coming in during a midday sun scene. And there's really no reason why any opening in the scene would have a different color to the skylight coming in. So for all the fill lights here, I'm going to use the same color, the same light blue color, and simply adjust the intensity multiplier of each light to control the relative variations in skylight coming in. And having done this enough times, I have an exact RGB value that I like to use for each of these lights, and that would be 180, 210, and 240. And that gives me a nice light blue color. And that's all the consideration I need to make for the color of the light, using a color that simulates the skylight for the time of day that I'm simulating. The intensity value of each light, however, requires more consideration. And from my quick review of the scene, I've gathered that these three lights that I've placed should have the greatest value of all the lights, but the real question to answer is what value should any of these lights have? If these lights that I just placed were the only window opening lights that I use, they would need to have a relatively high value, but if they were one of many such lights, which they are, there's many window and door openings, then they should have a relatively low value. Likewise, if I were trying to fill a much larger room than this with these lights, I would need to use greater values for the lights. In other words, if I was trying to fill a stadium with a couple lights, those lights are going to have a really high intensity value as opposed to a couple of rooms like this. There's quite a number of window and door openings in this room, so these 3 windows represent really a small portion of the total illumination, the total amount of skylight coming in. From experience in working with rooms of this size and with this number of openings, I know that a value of about 10 for the intensity multiplier will be a good place to start. And if I determine that these lights are set to a decent value, then I know what to assign all the other lights based on the relative light that should be coming in through each opening. So if I realize that another opening, another window or door opening has about half the amount of skylight coming in, then I would need to assign a value of 5 to that particular opening. With these first lights in place, I want to render the scene and see if I have a decent amount of light coming in these first fill lights. So when I render, the scene changes from this to this. It doesn't look like a tremendous amount of light was added to the scene, but again, this is just about 1/5 of all the light that's coming in through all these openings, so this looks fine for right now. I also notice that I see an immediate reduction in splotches and noise, although the previous rendering was so dark you really can't tell too much that there were splotches, but there definitely was splotches and noise in the previous rendering, and now it's reduced quite a bit. Now it's time to move on to the next set of fill lights. So I need to take another look at my scene from an aerial perspective and see what's going on next. So navigating around the outside of my scene, looking from the outside in, just trying to find the next set of lights that I want to work on, and I want to next work on placing lights in these windows right here. These windows don't face the sun like the first 3 lights do. In fact, they're facing about 90 degrees away from the sun, and because of that, they should clearly have a smaller intensity value. But the reason I want to work on these lights next is because they're part of the same room. Although the windows here in the bedroom are facing the sun just like the first 3 windows I placed, the first 3 lights that I placed in the windows, the only way the light in the bedroom will affect the living room is by coming through the bedroom door. And this bedroom door is fairly small compared to the entire amount of space in the bedroom. And this simply means that adding a light in the bedroom will have a negligible amount of impact on the total illumination in the living room. And because of this, these separate rooms can almost be treated as separate scenes from a lighting standpoint. And in just a few moments, I'll show you exactly the effect of the lights in the other rooms have. But for right now, I want to finish illuminating my living room, and I only want to work on adding fill lights to windows and door openings in the living room. And then I'll move on to the bedroom and the dining room. So this second set of 3 lights here in the living room should get about half the intensity value that the first 3 lights got, which means that once I create them, I need to change their intensity value to 5. And placing all of these lights is not hard by any means, but it can be time consuming. And instead of having you spend the time watching me place these lights, I want to start turning lights on that I already have created in the scene and just show you how I configure them and why, along with the updated images showing the effect of each light added to the scene. So I'm going to unhide these 3 lights that I already have created. And again, I've made these lights instanced and placed them just inside the window opening. And as I said, I set their intensity value to 5 and left the color at light blue. When the same camera view is rendered, this is what I get. A little more illumination to fill up the room. So the rendering changed from this to this. The next opening that I want to place a fill light in is for the living room sliding door here on the first floor. And this is a relatively large opening, but again, the size of the opening should have no bearing on the color or the intensity that I assign to the fill light. It certainly has a bearing on the first light that I create when I'm trying to decide what those values should be, what those initial values should be. But after I create the first light, I should only have to worry about assigning an intensity value relative to that first light. The fact that the fill light is larger means, of course, that more illumination will be projected than if the fill light were smaller, but I just need to assign a relative intensity value right now. And I can come back later if I decide that the overall total illumination is not correct after I fill all the openings with lights. But right now I'm just trying to assign a proper relative intensity value relative to that first light that I created with an intensity value of 10. So as with the last light, I've already created this light and assigned an intensity value. For this light, I assign an intensity value of 7.5, which is halfway in between 10 and 5, which I assigned for the first two sets of lights. And I assigned a value of less than 10 because the opening is oriented at a 45-degree angle to the sun, so less skylight is coming in for that reason. But I made it a little bit more than the 5 that I assigned to the second set of lights because unlike the last set of windows that I placed lights in, this opening has a lot of extra skylight coming in because of the direct light bouncing off the pool patio. So I gave the intensity of this light a value of 7.5, which is a good amount right in between the last two sets of values that I assigned the two sets of lights. As a side note, if after placing all of these lights I find that there's just not enough fill light and I can't offset it sufficiently with color mapping, then I would simply adjust the value of all the fill lights to the same degree. In other words, if I double the intensity value of the first set of lights, then I need to double the intensity value of this light that I just placed here. With this new light in place, my rendering changes from this to this. Notice the very unnatural reflection of the light that I can see on the floor in front of the door. To remove this unwanted reflection, all I need to do is disable the Effect Specular option within the light that I just created. And when I render with this option disabled, I see a proper looking reflection on the floor in front of the door opening. But I want to go back to the previous rendering that I showed just a minute ago before I place this light in the opening because I want to point out something really important. In this rendering, you see a small amount of noise on all of the surfaces with more noise on surfaces that receive less illumination. And I've pointed this out numerous times before, that surfaces with low illumination are more apt to receive noise. But what I want to point out is how much more noise is generated after I place this last fill light. The more light you add to a scene, the less noise you should see, but that's not the case with this last light that I just added. Look at the wall here on the right in this image. In this rendering, before the light is added, I only have a small amount of noise, but watch what happens when I switch to this next rendering here when the light is added. There's a lot more noise that's produced. And why would this be? Well, the reason is because where I place the last light. If I switch to a perspective view and rotate the view around a little bit to get a good look at the light from the outside, you can see that the light is positioned just outside the door opening. And unlike the previous set of lights that I placed this light outside because the curtains that were inside the window or inside the door opening that would interfere with the viewing light. The problem is, not only am I wasting light because of the tinting of the glass, I'm also inducing more noise because the light has to go through this glass and also part of the curtains in order to strike the surfaces inside the living room. And I can improve the render settings, which of course means greater render times, but if there's any way I can get away with placing this light inside the room, then I always will. So I want to try it here. I want to try to move this light so it's just inside this door opening. And I have to make sure that it's far enough inside that it doesn't interact with the curtains. So I need to place it a couple inches beyond the curtains. And when I do that, I want to see if the illumination looks okay and if the noise is reduced. So when I look at the rendering, it changes from this to this. And as you can see, not only do I have more illumination because I don't have the light going through the tinting and going through the curtains, I have much less noise. And the noise is reduced a little just by the sheer fact that I have more illumination, but more importantly, it's reduced because the light doesn't have to first pass through the glass and in some cases through the curtains. So this sort of highlights why you should try to place the light on the inside of an opening. And there's only two reasons why you wouldn't. or why you shouldn't. If you had an object obstructing the placement of a light just inside the opening, and the other reason would be if you had too much light burning onto the ceiling just in front of the windows, so much that it's not realistic. And we're going to look at this really closely when we do the dining room, because the dining room windows are really close to the ceiling, and when you have that kind of situation, you run the risk of having that light be too close to the ceiling and creating too much of a hot spot on the ceiling, and placing the light on the outside would reduce that. And we'll look to see when we work on the dining room if that really is more beneficial to place the light outside in that particular situation, or whether it is better to work with the light on the inside and try to make it work for the inside. Now I want to switch to an exterior view again to figure out what openings I should create lights for next. And the next set of lights I want to place are for the 3 windows just above the sliding doors that I created a light for last time. Again, these lights are already created, so I'll just unhide them and turn them on. Now, since these openings don't have the added effect of so much bounced light coming off the pool patio, I decided to use an intensity value of 5. And with these new lights, my rendering changes from this to this. I was considering cheating a little bit and bumping up this value to throw a little bit more light into the upstairs area where light's having trouble getting to, but after thinking about it, I realized it just wasn't necessary. There's enough light considering there's no lights turned on up there right now, and I could always open the doors to these rooms, and that would add a little more skylight into the hallway. But the reason these doors are closed in the first place is because the upstairs rooms were not part of the scope of the project. And nonetheless, it's fine as is. The next light I created was for the door in the back of this view, which is actually the front door. To come in this house, you have to walk through the pool area unless you come in the garage, and this is the front door. And anyway, the window in this door needs a fill light too, and again, I've already created the rest of the lights, so I'll simply unhide it and turn the light on. And for this light, I signed an intensity multiplier of 5 again. Since I already turned off the effect specular for the last light that I created, it's automatically disabled for any new light that I create, like this one. And when I render, my rendering changes from this to this. One other real quick note that I want to mention, since I'm on the subject of effect specular, if I enable the store with irradiance map option, the illumination from this light is stored with the irradiance map, which means if I save the irradiance map, I'll just save it to the hard drive and switch to from file and then load the file that I just saved. If I save and load this file, I can in fact turn off the light completely, so I can actually disable the light or turn it off, and it won't affect the rendering at all. This has the side effect of not allowing the light to be reflected in the rendering, because as far as V-Ray is concerned, the light doesn't even exist anymore. It's not going to show up because it's turned off. Yet its effect, its illumination, is still showing in the rendering because it was stored with the irradiance map. So I'll disable this option and go back to rendering in single frame mode, but I just wanted to point that out because that is one nice way to actually get that effect specular, that specular highlight from the light not to appear in your final rendering. Well, if I go back to the exterior view and look at what's left to, what openings are left to create lights for, I can see that there's only one more fill light to add in the living room, and that would be the sliders right behind the camera that I was just looking through. And I'll unhide these lights and turn them on. Now the doors here are facing 90 degrees away from the sun, but since the doors are on the first floor and there's another patio to reflect light into the opening, I decided to assign an intensity value of 7.5, which is halfway between the 5 and the 10 that I assigned to all the other lights. And like all the lights so far, this one is also inside the opening. I place it just inside. So with this new light, the rendering changes from this to this. Well, at this point, I've added all the fill lights that I need to have a real effect on the living room. And with all these fill lights, I see that I just don't quite have enough illumination yet. At least not as much as I would like to see in real life with a real house with all these window openings. I just don't see as much skylight coming in that I would see in real life if I was standing here in this room with a midday sun scene. And I have two options to fix this. I'm going to add artificial lighting in just a few moments, but I don't want to do that yet because, as I said before, it'll distort the natural lighting that I'm trying to set up. I don't want to add lights, artificial lights, because I want to make sure that the natural lighting is correct so that when I add the lights, the artificial interior lights, I'll know that the changes I see because of those lights are realistic. And all these fill lights are used solely to help simulate natural sunlight filling the interior. So my two options are increase the intensity multiplier of all my lights in relatively equal amounts. And remember, if I double the intensity of one, I need to double the intensity of all of them. And the second option is to play around with the color mapping. Either one of these is perfectly fine to a certain degree, but you never want to go too high with color mapping. In other words, you shouldn't use really high intensity multiplier values to compensate for far too little illumination. And this is really an important point, and I want to demonstrate this with a short look at another scene. And this will show why you shouldn't use excessive multiplier values.